today? Good. Well, my name is Shannon Jones, and I'm a floor educator at the Museum of Discovery. How many of you guys have ever been to the Museum of Discovery? Raise your hand. So quite a few of you have been. Awesome. Well, we have such a lot of stuff going on at the museum right now. We have summer camps that are in full swing right now. We have Lego summer camps. We have Minecraft summer camps. Yes, Minecraft. Isn't that awesome? Yes. And we just finished our Carnival Week. We have Steampunk Week coming up, and we even have a Zombie Survival Week coming up as our summer camps in the museum. We had Star Wars Day back in May. It's awesome. But coming up in July, we're having Superhero Day in July. So you guys make sure you go to our website and check that out. We have all kinds of cool activities. You can even dress up as your favorite superhero. So that is awesome. We have all kinds of stuff going on at the museum. I don't know if you guys know our Kevin Delaney that works at the museum. He's been seen on Jimmy Fallon a couple of times. Well, he's going to be on there again this Tuesday night on Jimmy Fallon doing some really cool experiments. You can see Kevin, he does a show at 1:30 on Saturdays, every Saturday. So if you guys are in our area, we'd love for you to stop by and check out one of his shows. Now today we're going to be doing an awesome science demonstration. Now these demonstrations we do throughout the week. We do them on the weekend. We have all kinds of floor shows. We even have animals. How many of you guys like animals? We have some really cool animals at our museum. We have a couple of baby hedgehogs. Yes. We've had them for a couple of months now. We have Daisy and Duke, who are our ferrets. We have snakes. We have lizards. We have all kinds of really cool animals. We have giant prickly sticks that look like big scorpions, but they're really not. So we have all kinds of cool stuff at the museum. So if you guys are ever in the area, come and stop by. The first Sunday of every month is Dollar Sunday. So we have lots of families that come through there on the first Sunday of every month. Now, adults, for you, the last Thursday night of every month, we have Science After Dark, and that's for adults only. So you guys grab babysitters and come on down. We have a different theme every month. We've had Game of Thrones, we've had UFOs, we've had all kinds of different themes. We have really fun, exciting stuff. We have pizza and drinks there too. So we have something for everybody. So if you guys are ever in the neighborhood museum, stop by and see me. Are you excited to get started? Yay! All right, so the first couple experiments we're going to do, I'm going to be using a very specific liquid. Does any of you know what specific liquid we're going to be using? Take a guess. Oil? Nope, not oil.
Vinegar.
No, not water, not vinegar. I have a very special liquid. What's your guess? No, not tea. That would be good to drink right now, wouldn't it? I have a very special liquid. It's called liquid nitrogen. It's called liquid nitrogen. Now, if you guys hold up your 10 fingers, hold up 10 fingers. Everybody hold up your 10 fingers. Okay? Now, pull your thumbs in. This is how much nitrogen is in our air that we're breathing. So we have nitrogen floating all around us. Now, take your thumbs and give me. That's how much oxygen is in our air. So believe it or not, we have nitrogen floating around all around us mixed in with our oxygen. But this nitrogen is very special because it's a liquid nitrogen. Now, do you see my big container up here? This is called a dewar. Now, this dewar is very special. How many of you have moms and dads that have like insulated travel mugs they put coffee in? Or maybe you have a Yeti cup that you keep something cool or hot? That's what this does. This is a big dewar. And this big dewar helps keep our liquid nitrogen cold. How cold, you ask? Do you guys want to guess how cold our liquid nitrogen gets? And I'm talking colder than ice. I'm talking colder than dry ice. So we have to have a special dewar to keep it cold. So you guys want to guess how cold our liquid nitrogen is? What's your guess?
No.
It's colder than snow. What's your guess?
-8.
Ooh, -8. He's going in the right direction, but it's even colder than -8. What's your guess?
-30.
-30. You're going in the right direction, but it's even colder than -30. What's your guess?
Space cold.
Space cold. Well, I've never actually been to space, but I'm pretty sure it's cold, but it's not quite that cold. So it's in between -30 and space cold.
-210.
Ooh, he is so close.
-220.
Oh, you're so close. We'll give you the gold star of the day. Our liquid nitrogen is -321 degrees Fahrenheit. Yes, -321 degrees Fahrenheit. So whenever I use my liquid nitrogen, I have to be safe about it. Any experiment we do here or in the museum, we have to take safety precautions. Now, I wear glasses naturally because of my eyesight, but if I didn't, I would always wear my safety goggles, my lab goggles to protect my eyes. Now, because our liquid nitrogen is so cold, I brought my handy dandy gloves with me. Now, these gloves help protect my hands and up my wrists. Now, if I were to take my hand and put it in liquid nitrogen, which I would not recommend at all, I would get severe freezer burn. You know how you have outside when it's cold and your fingers start tingling? Yeah, imagine that times like 1,000. So this is super cold, so we have to have a special container called a dewar to keep it really cold. Now, when I take the top off of my dewar, something really cool is going to happen. I want you guys to watch, okay? Are you watching? Can you see that fog coming off of it? Can you see that? The fog coming off of it? This is just the core. This is just the lid that goes on top of my dewar. This is what happens when the cold liquid nitrogen meets the warm air around us. It's creating that fog. Let's put it in, we'll pull it out again. It's kind of hard to see, but we're creating that fog. When that liquid nitrogen meets the warm air, it's heating up. So I'm going to set this aside and I'm going to put my gloves on because I always want to be safe when anytime I'm doing an experiment, I always want to be safe. So I have my glasses on, I have my gloves on. Now, when I pour my liquid nitrogen into my bowl here, I want you to watch and I want you to listen because two very cool things are going to happen when I take the liquid nitrogen from its dewar and pour it into our bowl. Are you guys ready? All right. So watch and listen. You see that? You hear that?
No.
That's pretty cool, isn't it? Look at that. That's what happens when the liquid nitrogen is actually boiling. Because when we take it out of its cool container and we put it into a bowl that's been outside of room temperature, it actually starts bubbling and boiling. So we're actually going to be cooking with liquid nitrogen. Isn't that cool? Yeah. So you see all of this? Are you ready? Watch. See all that fog that comes up? That's the same thing that came off of our lid when we pulled it off of the dewar. So now I have some everyday household objects that we're going to use. Now I have some rubber bands here. What are rubber bands good for? Besides popping your brother and sister. Ponytails. Like if your hair gets in your face, girls, and you want to pull it back, we use a ponytail to hold our hair back. What else could we use rubber bands for? Hold things together. That's the whole purpose of a rubber band, right? Is to hold things together. Because it's stretchy, it has elastic, and that's the thing rubber bands are known for, is to be stretchy and elastic, right? So rubber band is made up of molecules. You guys know what molecules are? Have you guys studied molecules in school? Some of you have?
Or the next smallest thing gets atoms.
Very good. So you have atoms and you have molecules. It's the step up. Now everything is made of molecules. The clothes that you're wearing, our table here, everything is made of molecules. Now in our rubber band, our molecules are spread farther apart, so that's why it's stretchy. Now my rubber band, I want you to watch. Regular rubber band, right? Stretchy. Okay, now, I'm gonna take my safety glove and put it back on. And I'm gonna take my rubber band, I'm gonna throw up my liquid nitrogen. Got another rubber band, it's stretchy also. We're gonna throw up my liquid nitrogen also. I don't know if you can hear this or not. It sounds like it's boiling, right? Because that's what it's actually doing, it's boiling. Now, I'm gonna take my tongs of science, actually just salad tongs, okay? And we're gonna mush up our rubber bands. Now, what do you think is gonna happen to our rubber bands once they got into liquid nitrogen? What do you think is gonna happen? Melt. You think it might melt? That's a really good observation. What else do you guys think might happen besides melting? What do you think?
The molecules are gonna get frozen solid and won't be elastic.
That's a very good observation. Remember, we just talked about molecules? What's your guess way in the back? You think so? All three of those are great observations, and that's what scientists do. When we experiment, we come up with hypotheses, what we think is going to happen, and then we test that to see what actually happens. So do you guys want to see what happened to our rubber band? Remember, it was stretchy just a minute ago? All right. That's my Hulk trick. I like that one. I go Hulk and smash. Did you see that? Did you see our rubber band when we put it in the liquid nitrogen and we pulled it out? I was able to snap it in half. Now, watch this. That piece that we snapped in half just a few minutes ago, it's stretchy again. Check that out. So what happens is the molecules, before we put in the liquid nitrogen, they're farther apart, so it's stretchy. So when we put it in the really cold liquid nitrogen, all those molecules came together. Now, what do you guys do when it gets cold outside and you forget your jacket? What do?
Never.
Don't you huddle up like this to get warm? That's what the molecules are doing. The molecules are heating up and they're expanding, and it goes back to expand form. When we put in here, all the molecules come together and they get really, really, really tight, and that's what's able to snap us. You want to see it again? I've got one more rubber band. You'll see it again? All right. That's super cool, isn't it? So we took a stretchy rubber band and we actually froze it. And then when we pull it back out and it heats back up, it's stretchy again. Isn't that cool? Yeah. All right, so the next thing we're going to do is we're going to play with some balloons. Now, I had my friends back here help me blow up some balloons earlier. And we're going to test them and see what happens when we put balloons in liquid nitrogen. Now, we know what happens to the rubber bands. They snapped. So I'll have some balloon friends down here that we're going to pull out. Pull out my little fishy here. You guys see my little fish here? Now, we thought about our rubber bands and what happens to those when we put them into the liquid nitrogen. And we came up with some hypotheses. So what do you think is going to happen to our balloon when we take our balloon and we put it into our liquid nitrogen? What do you think is going to happen? Okay, right here. It might pop. That's a good possibility. What do you think is going to happen?
Since all the molecules will huddle up, air molecules, like inside the balloon, the carbon dioxide and helium, it makes it where they're spread out, but if they get all close, it'll either deflate or pop.
That's a very good hypothesis. Now, he took what he learned from the rubber band experiment and he applied that to his balloon. Now, what we're going to do with our balloon is we're going to create a phase change. Do you know what a phase change is? Have you guys studied that in school? So types of matter are solid, liquid, and gas. Solid, liquid, and gas. So what would this be considered?
Gas.
It has gas inside of it, right? So when we blew it out, we blew air into it, or we blew gas inside here. So what happened is, when we're going to take this and put it in liquid nitrogen, we're going to cause a phase change. We're going to take it from one phase to another, okay? Are you guys ready? I want you guys to watch and see what happens. What's happening in my balloon? What in the world is going on with my balloon here?
The molecules are getting packed, so the air is not holding it up, and it's all going to one center part.
Now, I have another balloon here that my friends back here so lovingly made. We have a giraffe. You guys like our giraffe? They did a great job, didn't they, making our giraffe? So let's stick our giraffe down in there. Let's see what happens to our giraffe. Oh, look, the same thing's happening to our giraffe balloon. Do you think we fit another one in there? All right, let's see what else we've got. Oh, I've got a little weenie dog here. You guys like my weenie dog here? Yeah, a little weenie dog? All right, let's take my weenie dog and put it down in there. Look at that. So now we have a fish, we have a giraffe, and we have a weenie dog in our bowl of liquid nitrogen. And we have several guesses or hypotheses as to what is going to happen with our balloons. So you guys ready to find out what happens to our balloons? Are you watching? I don't know if you can see it, but there's liquid inside there. Are you watching? Isn't that cool? So we can take it and we can blow on it to help it along. Because our air, our breath, and our lungs, our air is warmer than liquid nitrogen. Pretty cool, right? So we're back to our fish balloon again. Now, I don't know if you guys could see it or not, but when we pulled it out, instead of the air inside of it, it was actually a liquid inside. So we created a phase change from a gas to a liquid. All right, let's check on our giraffe. Our giraffe was next, right? Let's check on our giraffe and see what happens with our giraffe. We can give it a little extra. Oh, thank you. And we're back to our giraffe. Pretty cool, right? We have our giraffe. Now, let's check on our weenie dog here. See? It's kind of hard to see outside, but there's liquid inside of our balloon. So we create a phase change from a gas to a liquid, and as it's warming up, it's going back to a gas. Isn't that cool? So we created a phase change. That's very cool. Now, I have one more. Oh, my fish balloon. It's okay. He likes to wander around and be free. It's all right. Now, I have one last balloon, and this is my absolute favorite balloon because it's called a rocket balloon. How many of you guys have ever seen a rocket balloon before? You guys seen a rocket balloon before? These are the absolute coolest balloons, and I'll show you why in just a minute. Do you think we can put the whole balloon down into our liquid nitrogen? You think so? No, I see some skeptics. All right, we're going to see if we can. If we can put the whole thing. Oh, thank you. We're going to see if we can put the whole liquid nitrogen. Oh, I see it's starting to deflate. I see it's deflating. Here we go. Oh, do you see that? Do you see what's happening? Look at our balloon. Do you see that? We're going to take it. I'm using my tongs because I never want to come in contact. My fingers never want to come in contact with the balloon. Okay? So we're going to wiggle it around in there. So we're actually cooking the balloon with our liquid nitrogen. Okay? Are you guys ready to see what happens? What happened to our balloon? You see it? Do you see it looks like a worm or like a little snake, doesn't it? Very cool, right? Awesome. So we've done rubber bands. We've done balloons. Thank you, sir. Thank you. We've done rubber bands. We've done balloons. Now, I have to go back to the museum after I leave here. So sometimes I like to have a snack during my show. Is that okay with you guys? If I snack a little bit and we'll keep doing the show? Is that okay with you guys? Now, these are my absolute favorite. How many of you love Cheeto Puffs? Like the best food in the world, right? Cheeto Puffs, they should be like a food group by themselves. Now, there's only one way that I like to eat my Cheeto Puffs. I like to eat my Cheeto Puffs cooked in liquid nitrogen. Yeah, you guys have never eaten Cheetos cooked in liquid nitrogen before? That's the best way to eat Cheeto Puffs is to cook them in liquid nitrogen. Can't believe you guys just don't have liquid nitrogen hanging around your house to cook your Cheeto Puffs with. I thought everybody did that.
You need a license
No?
to buy it.
Just me? Oh, that probably would be difficult, wouldn't it? So, I'm glad that you guys don't mind me having a little snack here while I'm doing this, because I have to go straight back to the museum and I might not have time for lunch. So I really thank you for letting me have a snack while we do our show. Now, here's my Super Cheeto. You see him? Doo-doo-doo. Super Cheeto. I just think that's cool. Okay, so. What's wrong? What? Smoke was coming out of me? Are you serious?
Yeah.
What happened? Where'd the smoke come from?
Liquid. You see?
What? I think you guys are messing with me. I didn't have smoke coming out. Doo-doo-doo, Super Cheeto. You see him flying through the air? I think you guys are just messing with me. There's no way the smoke. Come out my mouth. You guys are messing with me, right? What?
The Cheeto's not packed together and it has a space for the gas inside of it, so when you eat it, the gas is coming out from it and it can come out of your mouth or nose.
That is exactly correct. I gotta watch out for my job because I think you might steal my job.
Not legal.
Gotcha. He's exactly right. Our Cheeto is very porous. That means it has lots of holes for air to go in. So when we put the Cheeto inside the liquid nitrogen, it absorbs that liquid nitrogen, and when we put it in our mouth heats it up, and that way we're able to create that fog or that smoke. Now, I'd like to share, I'm not above sharing, so do I have a couple of adults who would like to come and try my Cheeto snacks? I have a couple adults. Juliana loves Cheetos. Come on up, you guys give Juliana a hand. Give her a round of applause. Yay! If you love Cheetos, you'll love liquid nitrogen cooked Cheetos. Okay, do you have dental insurance?
Yes.
No, I'm just messing with you. Okay, so Juliana is going to hold her hand out like this. And when I give her the Cheetos, she's going to take it and she's going to pop it in the back of her teeth where her molars are. And she's going to chew and not stop chewing. Okay? Just make sure that it doesn't touch your lips or your cheeks or your tongue or your, no, just kidding. Did you Super Cheeto? All right, you ready? All right, go for it. Yay! Choo, choo, choo. Choo, choo, choo. Isn't that cool? We turned Juliana into a dragon. She'll actually breathe smoke out. Thank you, Juliana. You guys give her a round of applause. Good job. You guys, one of you, want to come try? No? You guys want to come try? No? Come on. Come on. Are you ready? Now hold your hand out like this. I'm going to put it in your hand. You're going to put it in the back of your mouth where your molars are. Try to touch your tongue or your mouth, your lips. And I want you to chew, 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 okay? Don't quit chewing. Woo-hoo-hoo! Ha-ha! Choo, choo, choo! Good job. You guys give her a round of applause. Good job. Thank you. Volunteers. Thank you. I appreciate that. So, we did a rubber band, and we found out what happened in rubber band when we put in liquid nitrogen. We used balloons, and we took our balloons and put it in liquid nitrogen. Then we had our snack of our Cheetos, and we put it in liquid nitrogen. Now, because it's so warm outside, my liquid nitrogen is evaporating pretty quickly. So what I'm going to do is I'm going to pour some more into my bowl, and we're going to find out what happens when I have a ball pit ball, and I put it in there. Remember, safety first whenever you're doing any kind of experiment, and always have an adult available when you're doing an experiment. Never do one by yourself. So we're going to pour some more liquid nitrogen into our bowl because it's evaporating really quickly because it's warm outside. You guys see that? I don't know if you can hear that crackling sound, but it's actually boiling. The liquid nitrogen is actually boiling. So we're going to put our lid back on. Now, you guys are all familiar with ball pit balls, right? You see those, like if you go to Chuck E. Cheese or McDonald's and they have them in a ball pit? So I brought some with me. Just regular ball pit balls, nothing special about them. They're not trick balls. They're just plain ball pit balls. Now, what happened to the rubber band when we put it in there?
You could crush it because all the mold
Yeah.
packed in one place.
Our rubber band, when we put it in there, we were able to crush it. What happened to our balloon when we put it in there? What happened to it? It deflated. And we pulled it back out, we warmed it up, it inflated again. And then what happened to our Cheeto when we put our Cheeto in there? What happened to it? What happened to our Cheeto?
The liquid nitrogen gas got inside the Cheeto, so when you ate it, all the gas was released.
Very good. So basically what we're doing is we're warming things up, right? We're heating them up, and then we're cooling them down, and then we're heating them back up. So I have a ball pit ball here, just a regular ball pit ball. It bounces, kind of, okay? So what do you think is going to happen to my ball pit ball when I put it in there?
It's going to freeze kind of solid because all the molecules are going to go to one place and you'll be able to snap it.
Okay? Can you guys hear that? We're actually cooking our ball pit ball. It's bubbling, it's steaming up, and we're actually cooking our ball pit ball. Now we to our ball pit ball. You guys ready? What happened to our bouncy ball pit ball? Did you see that? It did. What we call an implosion. A lot of people think that's an explosion, but it's actually an implosion. What happens is all the air, the gas that's inside our ball pit ball, when we put it in the liquid nitrogen, all that gas expand. When we heat air up, it tries to expand. Well, it's trapped inside here, so it has nowhere to go. So that air is inside fighting to get out, fighting to get out, fighting to get out. So when we put it on liquid nitrogen, it freezes. There's no place for it to go, so it implodes. How many of you have seen buildings, like tall buildings, maybe a casino in Vegas or a tall skyscraper? They want to tear it down, but there's not any room to blast it out, so they have to implode it. So they put the charges, the dynamite inside, and make it go from the top down. That's basically what our ball pit ball did. And there's not one to show you, but it looks like a gunshot wound. It goes in one side and out the other, and it creates that explosion. Do you guys want to see that again? I'll do it over here this time for you guys to see. So that's basically what we did, is we took it, we put it in our liquid nitrogen, and we're freezing it. And we're cooking it till we hear the molecules in there slow down. Isn't that awesome? So we took a ball pit ball, it's kind of bouncy, and we made it implode. Thank you, sir. Thank you very much. We made it implode. Very cool, thank you. We made our ball pit ball implode. So that's another thing that happens when we use liquid nitrogen. So we've done a rubber band, we did a balloon, we did Cheetos, and we did our ball pit ball, which is very cool. So what I'm going to do is I have a big finale, but I'm going to save it for the very end. So I'm going to take my liquid nitrogen, and I'm going to scoot it over to the side. Now, we've been talking about phase changes, right? Taking a solid and making it to a liquid, or taking a gas and making it to a liquid. Well, how many of you know what this is? Do any of you know what this is? A trash can. Yes, I heard trash can. That is correct. It is a trash can, but not any just trash can. It is what I call a vortex cannon. Can you guys say vortex cannon? Oh, say it in your deep voice. Vortex cannon. Yes. So basically my vortex cannon is a trash can. It's very simple to make. You can do this at home. Take an old trash can, cut a hole in the bottom of it, and on the top here is just a plastic shower curtain that we've glued around the outside. Voila! You have a vortex cannon. Now our vortex cannon is really cool because what does a cannon do? Yeah, a cannon is very loud, doesn't it? And it makes things flow. When I do this, you can hear it, but you really can't see anything, can you? Like if I got up close, come stand right here, sweetie, for me. Come stand right here. If I got really close, watch his hair. You see his hair? We can hear the drum, but we really can't see anything, can we? Now I can move air with my drum. That's really cool, right? If I hit it, I'm making air move, right? We can hear it, but we can't quite see it, can we? So what we can do though, is we can take a tablecloth. And can I get one of you ladies to come help me out? All you have to do is hold the tablecloth for me. Now, this is just a plain regular tablecloth, nothing fancy, you get them at the dollar store. So what I want you to do, I want you to hold the top of this, like way up there. Okay, now, we have some wind helping us. We have some wind helping us out. But if I were to take this and move it, hold one hand at the top and one hand at the bottom. There you go. If I were to take my cannon, we can see the tablecloth moving. Okay? If I step back, we can still see it moving. I can keep going back. See how good my aim is. Oh, there was one. And it's moving. But we really can't see it, can we? It would be cool if we could see it, right? Thank you. So we can hear the drumming when I hit on it. We can see the air moving against the tablecloth. But it would be cool if we could actually see the air moving, right? So what I'm going to do is I'm going to take my handy dandy fog machine. Everybody needs a fog machine. Okay? I'm going to take my fog machine and I'm going to fill up my vortex cannon with fog. And this way it's going to help us actually see the air moving around. Okay, so when I put our fog inside our vortex cannon, you can actually see our air moving. You see the rings? Do you see the little rings that are shooting out? We call them donuts at the museum, but they're actually called toroids. Can you guys say toroids? Toroids is the ring shape that you see coming out of our vortex cannon. So next time you go to the donut shop, ask them for a toroid and see what happens if they completely understand what you're saying. You guys want to see that again? That's pretty cool, isn't it? So we're going to fill it back up, our fog machine. We're going to fill it back up. And then our fog, once we have fog inside here, actually, when you see the ring coming out, it's moving the air around it. Our fog machine has a mind of its own. Oh my goodness. Let's see if we can capture some of this fog. So what happens is, in the toroid, when it's spitting out of the vortex cannon, it's actually moving faster than the air around us. So the toroid will actually keep its shape for a long time because it's actually moving faster than the air around us. Aren't those cool? This is really cool to do if you have like LED lights in your house or if you have LED lights outside. If you'll shoot the toroid towards an LED light, it lights up like it's neon. It's really super cool. We have LED lights in our theater at the museum. All right, pretty cool, right? So those are toroids, vortex cannon, super easy to make, all kinds of fun, fog machine, and you got a party. All right, so you guys have been such an awesome audience. I have one last experiment. This is the finale. I only do this if I have really great audiences, and you guys have been awesome. So, what do you think is going to happen when we take something really hot and combine it with something that's really cold?
Freeze.
It might freeze?
Oh, no.
That's a good hypothesis. What do you think right here in the front? What do you think is going to happen right here?
Well, more gas over here.
You think so? Could be, maybe. Now, remember at the beginning of the show when I said that liquid nitrogen was really cold? Do you guys remember how cold it was? Negative 310 degrees. Now remember I told you, what was this called? A dewar, very good. And it's kind of like your mom and dad's insulated coffee cup that they take to keep stuff hot. Or if you have a Yeti cup that keeps it cold or hot, that's what our dewar does. So remember I said our liquid nitrogen is negative 321 degrees Fahrenheit? Now, I'm going to add something that's really hot. So we have negative 321 degrees Fahrenheit liquid nitrogen. Now, while we've been doing our experiments, I've had hot water boiling. Now the hot water gets to 212 degrees on the positive side. So we have a vast difference of really cold and we have a vast difference of really hot. So we have several different hypotheses about what they think is going to happen. Now, when I take my liquid nitrogen, I'm going to pour it into this container because it's easier to contain. Now, what we're going to do is we're going to pour our liquid nitrogen into this container here, okay? Now, as we experiment, do you see the bottom of the bowl? I'll show it to you in just a minute. We're going to pour liquid nitrogen into our beaker. Are you guys watching? It's really cool, right? Okay. Now look at our bowl that we've had liquid nitrogen in. What did we make? We made snow in June. How cool is that? Do you see that? Yeah, we actually made snow in June. How cool is that? So, our liquid nitrogen is here. Now remember what I told you a while ago? It's really hot outside, so our liquid nitrogen is evaporating quickly. So I'm going to pour some more into our container. Now I always want to be safe. Remember, safety first when we're doing experiments. So I'm going to pour it into this container here. We're going to pour some more in. Do you see how fast our beaker has frozen? Do you guys see that? It was not just a couple minutes ago. And now our beaker is frozen already. All right. So we're add a little bit more liquid nitrogen. I'm going to place it over here out of the way because we don't want it to get into our experiment. Now, I'm going to take this, I'm going to pour it into our big container here. Now, do you see our beaker here? It wasn't maybe 2 or 3 minutes, right, when we put the liquid nitrogen into our beaker? But look, that's how long it takes. See, we created again snow in June. Pretty cool, right? All right, so we have our liquid nitrogen. Now, we're going to add our hot water. And some of our hypotheses were it's going to freeze. Some of you said that it's going to get bigger. What's another hypothesis you think is going to happen?
It's going to do a tornado. It's going to make a tornado because it's hot.
A tornado, you think so? Possibly, because that's when we get our bad weather, right? When we have a hot front and a cold front come together. Well, I hope you guys are ready for this, because this is super awesome. This is like my favorite experiment like we do in the museum. Are you guys ready? Oh, I don't believe you. Are you guys ready? Yes. I still don't believe you. Are you ready? Yes. Right. Can I get a countdown? 5. Whoa, whoa, whoa. That was a weak countdown. Let's start again. Let's start from 5. Are you ready? 5.
4, 3, 2, 1.
How cool was that? Was that not cool? Now, look at our container. I like to pretend I'm a choo-choo train. Choo-choo. 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 Do you see that? What we did is we put something really cold and something really hot together, and we made it expand quickly. And when it expanded quickly, that's when it went up and out because it had no place else to go. So that's what happens when you put together something really cold and something really hot, you make it expand. It looked like a big giant cloud, didn't it? That was really cool, wasn't it? You guys have been a tremendous audience. I thank you so much for coming out today. If you're ever in our area around the Museum of Discovery, come inside and see me. Say hello. We have these theater shows during the week and during the weekend. We have floor demonstrations. We also have animal walkabouts. We have some of our people walking around with animals. So if you guys are ever in our neighborhood, stop by and see me, okay? Thanks for coming. You guys have been a tremendous audience.